Hello everybody. Welcome to today's video. Today we will learn how the massive aircraft structure flies. Come, let us learn something new today. In order to understand how aircraft flies, we must enter the world of fluid mechanics. Even clear skies aren't empty. The atmosphere is a massive fluid layer. In order to achieve flight, we have to exploit the four basic aerodynamic forces: thrust, drag, lift and weight. These four forces holds the aircraft in the air, each pushing from a different direction. First, let's examine thrust and drag. Thrust is the aerodynamic force that pushes or pulls the airplane forward through space. The opposing aerodynamic force is drag, or the friction that resists the motion of an object moving through a fluid. A simple example of drag is sticking your hand out of a car window while moving. The amount of drag that your hand creates depends on a few factors, such as the size of your hand, the speed of the car and the density of the air. If you were to slow down, you would notice that the drag on your hand would decrease. For an aircraft to fly, thrust must be equal to or greater than the drag. If, for any reason, the amount of drag becomes larger than the amount of thrust, the plane will slow down. If the thrust is increased so that it's greater than the drag, the plane will speed up. Every object on Earth has weight. An aircraft has an approximate takeoff weight of about 485 tons. This weight acts as a force on the plane and pulls it downward towards the Earth. The force that opposes the weight is called lift. This helps hold the aircraft in the air. This feat is accomplished through the use of a wing, also known as an airfoil. The lift force occurs when a moving fluid is deflected by a solid object. Similarly, the wing splits the airflow in two directions, up and over the wing and down along the underside of the wing. The air moving over it travels faster than the air moving underneath. When moving air flows over an object and encounters an obstacle, its path narrows and the flow speeds up as all the molecules rush though. Once past the obstacle, the path widens and the flow slows down again. Similar to a pinched hose. As air speeds up, its pressure drops, so the faster moving air moving over the wing exerts less pressure on it than the slower air moving underneath the wing. The result is an upward push of lift. This is called Bernoulli's principle. In order to understand change of altitude better, we need to consider angle of attack. It is the angle that a wing presents to oncoming air. Angle of attack is directly proportional to the lift produced. A typical wing has to present a negative angle of attack in order to achieve zero lift. Airfoil shapes vary depending on the aircraft, but pilots further alter the shape of the airfoil in real time via flaps and slats. During takeoff and landing, the flaps extend downward from the trailing edge of the wings. This effectively alters the shape of the wing, allowing it to divert more air, and thus create more lift. The alteration also increases drag, which helps a landing airplane slow down. Slats perform the same function as flaps, but they're attached to the front of the wing instead of the rear. The tail of the airplane has two types of small wings, called the horizontal and vertical stabilizers. A pilot uses these surfaces to control the direction of the plane. On the horizontal tail wing, these flaps are called elevators as they enable the plane to go up and down through the air. The flaps change the horizontal stabilizer's angle of attack, and the resulting lift either raises the rear of the aircraft or lowers it. Meanwhile, the vertical tail wing features a flap known as a rudder. It enables the plane to turn left or right and works along the same principle. Finally, we come to the ailerons, horizontal flaps located near the end of an airplane's wings. These flaps allow one wing to generate more lift than the other, resulting in a rolling motion that allows the plane to bank left or right. To the untrained eye, a panel of flight instruments may seem like a smorgasbord of dials. But all these crucial gauges provide a pilot with critical data during the flight. The five most basic flight instruments are: airspeed indicator. This gauge tells the pilot how fast the aircraft is traveling in relation to the ground. Altimeter. As the name implies, an altimeter measures altitude. Attitude indicator. illustrates the aircraft's orientation. Heading indicator tells the pilot in which direction the plane is heading. Variometer, also known as a vertical speed indicator. This device indicates the rate of a plane's rate of climb or descent. Air pressure changes depending on altitude. Air pressure decreases the higher you ascend through the atmosphere. When humans breathe thinner, high-altitude air, they have a harder time taking in enough oxygen. Pressurized cabin are used in aircrafts. While the air outside the cabin thins out the higher a plane climbs. Compressed air inside the cabin maintains more surface-level air pressure and oxygen-rich air. In the event of accidental loss of cabin pressure, emergency oxygen masks provide the necessary air quality. With this we come to the end of today's video. Hope it was useful and you have learned how aircrafts fly. Kindly keep supporting DRM Engineering. Also do subscribe to the channel if you haven't. We'll meet you in the next video soon.